It is day 6 of me figuring out onset detection, and behind me there is this beautiful cat called Carlos. Hello, Carlos. And I finally figured out the crash situation that I suffered from, and now it works fine. Check out this beat, and then check out the onset detection. So we can see that the beat is quite filled with different kinds of sounds that are interacting with each other, and the onsets are only poking out very softly. You can barely see them. You can see that there is a different frequency here, but it's not like much higher in amplitude. And then there is also this one, and this is obviously the kick, but it is not very onsetty. Like it is starting with a large, low frequency thingy. Like it's not the typical kind of kick. So will these onsets be detected? Yes or no? At the beginning there's always some sort of large chunk of onsets that don't really fit, but then suddenly it's kind of rather consistent. Maybe a little bit more hold length. Yeah. Not quite. Yeah. But it does work, and it doesn't crash. So I solved that. The first thing that I changed was that I went into my sysax message class and I said that my developer ID is not these 3 numbers anymore, but the last number is being wrapped around 128, which you do by doing this. And the reason for that is because the hex value for 91 is above the range of possible numbers of U and 8T. So this expression would be undefined behavior without wrapping it back at 128. And I chose these numbers because that's my birthday. So I didn't want to drop the 91 completely, so I just kind of made it legit now. But that wasn't even the actual problem of my code. That wasn't the crash situation. The crash situation happened in this method. A little earlier it still looked like this, basically saying if there is a sysax message at the end of this block, then get the size, and if the size is not 0, then that means that it's actually a valid type of event. So get the event and check out if the event is a sysax message. If yes, then get the moment in time where the onset occurs, and then take that as an index and write a 1 there. That's what you saw. You saw these impulses in the oscilloscope. That is basically this code. Now the problem with this, do you spot it? The problem with this, if you watched my other video that was about this structure where you first run the audio buffer and at the end of each block you have one MIDI event, that is this exact thing again. But the problem with this is that the onset index is actually at all times at num samples, because we have rearranged the buffer in a way that the event is always at the end of the audio buffer. So when the audio buffer has just ended, then that is the moment of the event. So what the event does should only influence the upcoming samples. That is why what is written here would actually go out of bounds. This is not the right way to do. Instead, the correct way to deal with this kind of code now is that you have somewhere a local variable called onset detected or something. Obviously it should not be static in actual production code, but this is just for demonstrational purposes. So some class, some DSP class, and it reacts to the event, for example with a bool that can change its state. And then you would just go here and say, yeah, onset detected, bro. So next time this process is being called and there are actually samples in the buffer, then we say that the onset is not detected anymore because we are now processing this event, and then we can actually put something into the buffer, into the first place of it. We do not have to care for the actual index of the onset. That is something that I need to get used to myself, even though I came up with that. The fact that you don't really have to work with timestamps anymore within this architecture, that is kind of cool. But yeah, it's a little bit different.